Okay, so we have a question here. It says sales of products for the last 12 months are shown below. Okay, so we've been given the months from the first month to the 12th month. We've also been given the sales. All right. So basically, we're trying to ask ourselves, is there a relationship between the sales and the months? Because regression analysis is all about finding out a relationship between two variables using the equation of a line. All right. So the first part of this question is what is the use of a scatter plot diagram in regression analysis? Well, the scatter plot diagram gives us the visual relationship of these variables. Okay. When we plot a graph with these figures here, we'll be able to see the type of relationship these variables have. Okay, so as I start making my table and doing the calculations, I'm going to show the graph so that you can see visually if there is a relationship between the sales and the month. Okay, so but the purpose of the scatter plot diagram is just to show you visually the type of relationship which is between the two variables. Okay, that's the use to visually see the relationship. Part B, they said find the equation of the regression line. Okay, so the equation of the regression line is like this. Let me bring this here. Yes. Y equals A plus BX. Y is the dependent variable. Okay, it's dependent on X. So in this case, our Y is the cells. So assuming the cells are dependent on the month. Okay, X is the independent variable. Okay, it's not dependent on anything. So here the months are not dependent on anything. A is the y-intercept. Okay, this is the value of the cells when the month is 0 or when X is 0. Okay, an intercept basically is where the line cuts the y-axis, a y-intercept, where the line cuts the y-axis. Okay, and it also represents the value of your y variable, the dependent variable, when your independent variable is 0. Then B is the slope. Slope is just the rate of change. Okay, the change in your y variable for each unit change in X. So if you increase X by 1 unit, Y is supposed to either increase or decrease by a certain amount. That's the slope. Okay, so for example, if we say the slope is 2, it means if we increase the X variable by 1 unit, Y is going to increase by 2 units. Okay, if we increase X again by another unit, Y is going to increase again by 2 units. Okay, so we have to find the equation of the regression line. So let me just put the information here. We've got our cell, our month, and our cells. Okay, put our variables there. Let's see the scatter plot so we can visually see this relationship. Um, okay, so colleagues, have you seen this? Is if you plot this graph, all right, this is the type of scatter plot diagram you're going to see. Okay, so if you draw a straight line here like this, it's like we've got some form of positive relationship, meaning when the months are increasing, also the sales are increasing. Okay, that's the visual relationship we can see between the month and the sales. Remember, sales is on the y-axis, it's the dependent variable, it's dependent on the months, which is your x variable. Any questions before I start doing the calculations? So this is the scatter plot diagram we're talking about in part A. All right, it gives you a visual of the relationship between the two variables. Now we need to get the regression line, the equation. So I'll put the scatter plot this side, and now we need to get the equation. Could you just mute your mic? Mute your mic. Yes. When you are trying to get this equation of the regression line, remember, first thing you need to do, you need to multiply x by y. Okay. So 1 times 89, you're getting 89. 2 by 74, we get 148. 3 by 92, you multiply each x variable with a y variable. 4 times 123, you multiply. Okay, that's the first thing. Multiply each x variable by y. Then the next thing, you need to square your x variable. Okay, so each value of x, we're going to square it. 1 squared is 1. 2 squared is 4. 3 squared. Okay, we're squaring each x variable. Okay, all these values of x, you're going to square them. Then also y, all the values of y, you're going to square them too. Each value of y, you square it. Right? Those are the first things that you need to do. Then you get your totals. Yeah, so for x, you total up everything for x, all the values, you add all of them, get the total 78. For y, the same thing, add them up, get all the totals, 1575. For xy, again, also get all the totals, for x squared, get all the totals, and for y squared also get all the totals. So these totals, okay, they're the ones you're going to see in the formulae. All right, so let me just draw them down. This is sigma x, total of the x values. This is sigma y, total of the y values. This is sigma xy. This is sigma x squared. This is sigma y squared. Okay, so these totals are the ones we're going to apply in the formulae. So let me bring the information for the formulae. Let's see. Yes. Move this aside. All right, so we start by getting our slope b here. If you can see the formula here, I hope we're able to clearly see the formula. B equals sigma xy minus sigma x multiplied by sigma y over n. N, as I said, is just the number of data values that you have, basically. Okay. In this case, we have 1, 2, 3, 12 data values. So n is 12. Okay. So n, number of the data values, 12. Okay. And then here we've got sigma x squared minus sigma x squared over n. So it's just a matter of replacing here. So sigma xy, here it is. This is 11,538. Minus sigma x, which is 78, multiplied by sigma y. Sigma y is 1,575. Well, 575 divided by n, the number of data values, which is 12, over sigma x squared. Sigma x squared is 650. minus sigma x squared. So sigma x is 78, then we're going to square it. So be careful between these two here, okay? This one at the bottom, it's sigma x squared. So it means just the total of x, then you square it. We're going to have over 78 squared over 12. Okay, so we do our tabulations. So we start 78 times 1575. You get 122,850. 122,850 divided by 12. You get 10,237.5. So on our numerator here, we have 11,538 minus 10,237.5 divided by, here we have 650 minus, so we do 78 squared. 78 squared 6,084 divided by 12. 6,084 divided by 12, we get 507. 507. All right. So we say 11,538 minus 10,237.5, you get 1,300.5. Divided by 650 minus 507. 143. So 1,300.5 divided by 143, we get 9.09. So we have a positive slope. Okay. And as we can see with our scatter plot diagram, as you can see, it's like the dots are going upward like this. This represents a positive slope. Okay. If your B is negative, okay, expect the line or the dots to be going down like this. Okay. So here we have a positive slope, which we can also see here in our scatter plot graph. We can see an upward trend. Any questions before I find A? Okay, we need to get our intercept. So A equals sigma y. Sigma y is 1575. Yes, it's this question here. It's this question here. It's more like an expansion of the one last time. N is 12 minus B 9.09, open brackets, sigma x 78 over N, which is 12. Okay, so we do our tabulations. 1575 divided by 12, 131.5, minus, because we divide 78 by 12, 78 divided by 12, we get 6.5. 6.5 multiplied by 9.09, we get 59.11. So one, oh, it's 131.25 here. So 131.25 minus 59.11. So 131.25 minus 59.11, you get 72.13. Okay. So basically, these are the cells when the month is zero, your y-intercept. Okay, remember the y-intercept is when x is zero. It's the value of y when x is zero. So in this example here, when the month is zero, these are the cells, 72.13. So we can now form our equation. Y equals A 72.13 plus B, B is 9.09 x. Okay, this is the equation of our line. 72.13 plus 9.09 x. Any questions? B. A was this graph here. Or A was just asking what is the use of the graph. And we said it's to see visually the relationship between the variables. So B, we found the equation of the regression line. It's to see visually the relationship between the variables. I'll send all these notes once I'm done. But the purpose of the scatter plot, this diagram here, is so you can visualize the relationship between cells and the months. Use the linear regression to forecast sales for the next months. So once you've formed your equation, you can now make forecasts. Okay, you can now predict in the future how much will we expect to sell in the 13th month and the 14th month. Since it says for the next 2 months, so the 13th month, because we ended on 12 months, 13th month and the 14th month. Okay. So we're going to substitute 13 for X to find the sales for the 13th month. And we're going to substitute 14 for X to find the sales for the 14th month. Okay, so for the 13th month, mute your mic, it's giving feedback. So for the 13th month, we say Y equals 72.13 plus 9.09. Then we substitute 13 in there. So we're going to say, let me put this here. The values here 72.13, and we've got 9.09, and we have, I'll put here 13 and 14. All right. So first things first, for the 13th month, you're going to say 13 multiplied by 9.09, 118.17. 118.17 plus 72.13, 190.3. So these are the sales for the 13th month, 190.3. Then for the 14th month, same thing. So we're going to say 14 multiplied by 9.09, we get 127.6. plus 72.13. Oh, the main class. Okay. Let me just finish this part. Okay. So, okay. The cells are going to be 199.39. Yes. So we can pause here then. We can pause here. Then next time when we meet, we're going to find the coefficient of correlation, this R, to measure how strong this relationship